Hello, welcome to the series on the playlist of videos on essential concepts of probability for data science. I am Hemakumar Kasala and I wish to introduce you to the concept of Bayes rule in this session. It is essential that you have gone through the previous videos on basic concepts and definitions on probability, conditional probability and basic properties on probability before watching this session. Let's get into the session. Bayes rule. Let's try and understand Bayes rule via the example that we used to understand the law of total probability in the previous video. A shop sells two brands of TVs, brand X and brand Y. Bx is the event that brand X TV is purchased whose probability is probability of Bx, and By is the event that a brand Y TV is purchased whose probability is probability of By. Let's for the time being not consider the values for probability of Bx and probability of By and other probabilities that we discuss further below in this example. Bx and By are disjoint events whose probabilities are known and sum of their probabilities equal 1. That is, the total probability equals 1. And E is the event that an extended warranty is purchased for each of the TV being bought, whose probability is probability of E. Probability of E given Bx is the conditional probability that extended warranty is purchased given that brand X TV is purchased. Probability of E given By is the conditional probability that extended warranty is purchased given that brand Y TV is purchased. Probability of Bx given E is the conditional probability that brand X TV is purchased given that the extended warranty is purchased. Probability of By given E is the conditional probability that brand Y TV is purchased given that extended warranty is purchased. Using the values that we discussed in the previous video, probability of Bx equals 0.55, probability of By equals 0.45, probability of E given Bx equals 0.2, probability of E given By equals 0.25, probability of E equals 0.225. We see that the values for the conditional probabilities, probability of E given Bx and probability of E given By are known. However, the conditional probabilities, probability of Bx given E and probability of By given E are not known. Is it possible to derive the unknown probability of Bx given E and probability of By given E from the known probability of E given Bx and probability of E given By? The answer is yes, and the solution is provided by the Bayes rule. Let's derive the Bayes rule then. Applying the conditional probabilities, we have probability of E given Bx equals probability of E intersection Bx divided by probability of Bx, and probability of Bx given E equals probability of E intersection Bx divided by probability of E. From the above, by moving the denominators to the left hand side and rearranging, we get probability of E intersection Bx equals probability of E given Bx multiplied by probability of Bx, which also equals probability of Bx given E multiplied by probability of E. That leads to probability of Bx given E equals probability of E given Bx multiplied by probability of Bx divided by probability of E. The above derived equation is the Bayes rule applied in the context of the current example. Probability of Bx given E, the unknown conditional probability that brand X TV is purchased given the extended warranty is purchased, can be computed from probability of E given Bx, the known conditional probability that extended warranty is purchased given brand X TV is purchased. Note, the reverse is true as well, that is, probability of E given Bx can be computed from probability of Bx given E if probability of Bx is known and probability of E given Bx is unknown, though that is not the problem statement in this example. That is, probability of E given Bx equals probability of Bx given E multiplied by probability of E divided by probability of Bx. And similarly, probability of by given E equals probability of E given by multiplied by probability of by divided by probability of E. That is, the probability of by given E, the unknown conditional probability that brand Y TV is purchased given the extended warranty is purchased, can be computed from probability of E given by, the known conditional probability that extended warranty is purchased given the brand Y TV is purchased. As noted in the previous case, the reverse is true as well. That is, probability of E given by can be computed from probability of by given E if probability of by given E is known and probability of E given by is unknown, though that is not the problem statement in this example. Thus, probability of E given by equals probability of by given E multiplied by probability of E divided by probability of by. And thus, using the various probability values available as part of this example, the unknown conditional probabilities, probability of Bx given E and probability of By given E, can be evaluated using the known conditional probabilities, probability of E given Bx and probability of E given by applying the base rule, as in probability of Bx given E equals probability of E given Bx multiplied by probability of Bx divided by probability of E, which equals 0.2 multiplied by 0.55 divided by 0.2225, which in turn equals 0.494. And probability of By given E equals probability of E given By multiplied by probability of By divided by probability of E, which equals 0.25 multiplied by 0.45 divided by 0.2225, which in turn equals 0.5056. Generalizing the above equations, we can state probability of x given y equals probability of y given x multiplied by probability of x divided by probability of y, and probability of y given x equals probability of x given y multiplied by probability of y divided by probability of x, where x and y are two separate events. The above derivations state the base rule in its simplest form. That is, derive the conditional probability of event x given y from the conditional probability of event y given x, and vice versa. Note, the individual probabilities of x and y, probability of x and probability of y, are assumed known. Having said that this is the base rule in its simplest form, it has an extended or a more complete form as well. In order to arrive at the extended form of the base rule, let's get back to the example case and take a look at the following two conditional probabilities. That is, probability of Bx given E equals probability of E given Bx multiplied by probability of Bx divided by probability of E, and probability of By given E equals probability of E given By multiplied by probability of By divided by probability of E. Since events Bx and By are disjoint and sum of their probabilities, probability of Bx plus probability of By equals 1, law of total probability can be applied for probability of E in the denominator of the above equations and can be expanded as in probability of Bx given E equals probability of E given Bx multiplied by probability of Bx divided by probability of E given Bx multiplied by probability of Bx plus probability of E given By multiplied by probability of By, and probability of By given E equals probability of E given By multiplied by probability of By divided by probability of E given Bx multiplied by probability of Bx plus probability of E given By multiplied by probability of By. The above equations represent the base rule in its full form for the current example. Base rule can be extended for n disjoint events and a general form for base rule can be arrived at. Given B1, B2 and so on until Bn are n disjoint events whose total probability of B1 plus probability of B2 and so on until probability of Bn equals 1, and E is an event that shares its outcomes across the n different disjoint events, Bayes' rule in its general form can be written as probability of Bi given E equals probability of E given Bi multiplied by probability of Bi divided by probability of E given B1 multiplied by probability of B1 plus probability of E given B2 multiplied by probability of B2 and so on until probability of E given Bn multiplied by probability of Bn. Thus, to summarize, Bayes' rule in its more generic and extended form states that the conditional probability of one of the disjoint events Bi given an event E that shares its outcomes with some or all the disjoint events can be derived by making use of the conditional probabilities of that event E given each of the n disjoint event Bx and the individual probabilities of Bx for all n values of x. That brings us to the end of the session on understanding the Bayes rule. Please share your questions and remarks if any, and I'll try and respond back as soon as possible. Thank you, and see you with the next session on the playlist of videos on the essential concepts on probability for data science. Bye until then.